Hello everyone. This presentation is of a web search engine that we have developed as part of the final project for the course Advanced Computing Concepts under the guidance of Dr. Al-Khatib. This engine is completely developed in Java. Over the course of this presentation, we will be going through the basic introduction of what is a web search engine, the features we have incorporated as part of our project, and then a brief description of each feature by each of our team members, followed by a live demo of the product, and then the future scope and conclusion. We are a team of 4 members, that is Zorawar, Usha, that is me, Divya, and Zainab, who have developed this product. You will listen from each one of us during the course of this presentation. Firstly, what is a web search engine? A search engine is basically a piece of software that searches through the web in a systematic way for particular information, often provided in textual format by the user. Then the search results are generated in a form of results or pages, often referred to as SERPs. As part of our product, we have incorporated the following features. First step is the crawler, which is a discovery process in which search engines scours the internet for content and sublinks for a given base URL. Next, once we have all the links from the crawler, then comes the parsing, where all the links, the HTML content is parsed, removing all the HTML tags, and only text is filtered and stored in text files. This feature is the HTML to text file conversion. Then comes the keyword extraction, where all the text files are traversed to find the alphanumeric words, and those words are stored and indexed. After keyword extraction, we do page ranking, which helps us find the best answers for a searcher's query, which means the results are ordered by most relevant to the least relevant based on a page ranking algorithm. The final feature we have implemented is a similar word suggester. That is, for a given user's search query, if no results are found, then our search engine suggests words that are similar to the user's query for which information can be found. Now, I'll hand over the control to Divya to take forward this presentation and talk in detail about each of the features.
Thank you, Usha. So the first feature we have incorporated into our project is the web crawler. So what is a web crawler? A web crawler is a computer program that automatically searches documents on the web. These are primarily used in web search engines to browse the internet and build an index. So similarly, in our project, this feature enables us to search for the relevant content on the websites in order to perform web indexing. So how does it work? What exactly happens is that firstly, JSON library will be connecting to a base link that is provided, and then our process recursively searches and gets all the sublinks for that domain, that is w3.org in our project, and then these sublinks are verified according to maximum depth and maximum number of URLs that is needed and stored in a text file. This generated text file works as an input for our next feature, that is HTML to text conversion. So as said, the next feature is HTML to text file conversion. This feature allows to convert HTML links to text files. So the JSON library is used to change the text from the URL links provided by the web crawler from the first feature, and all the text files are downloaded and stored in .txt format. The reason why we are using a HTML to text file conversion is that in a web page we have multiple elements like links, folders, images, and even videos, and all these elements are embedded under HTML tags. Since the purpose of our proposed search engine is only search for textual format, we need to filter all those unwanted elements, and also directly accessing the links on web is highly dependent on network speed. So we parse the links to get only the text format and store them in the memory to enable faster processing for next feature. So the next feature is keywords extraction. I would like my teammate Zainab to continue with the third feature, that is keyword extraction.
Oh, thank you, Divya. Now, our next feature of this web search engine is keywords extraction. With this feature, keywords are extracted from the text files which were generated in the previous feature and then stored in a hash map. In addition to this, keywords are also searched despite of their case sensitivity as well as picking any special characters. So yeah, the entire process is being done using regex method. So moving to the next slide, I will explain how this works. Firstly, there are two data structures that are used here to those keywords that are extracted from the text files, namely hash data structure and try data structure. Besides that, for reading those alphanumeric characters, here regex pattern is used. Therefore, the generated try will be stored into the dat file so that it can be accessible quickly by the search engine. So yeah, that's it for this feature. Now I would like to call.
Thank you, Zainab. This feature, page ranking, is quite an important part in our project. It helps us in ranking the page based on the frequency of the words. Now, talking more about page ranking and how it works, we can consider a simple example here. Whenever user enters any text word, that particular text word is searched in our project, wherein we have a file known as keywords.dat file. In keywords.dat file, we are storing URL as a key and its value, which will have all the keywords related to that URL. So we have all the entries in key value pairs for all the URLs and its particular keywords in our search engine. When that mapping is done, we then search that particular text word for that keyword in that file. So whenever we find that word which is present in that keyword.dat file, we get to know the occurrence of that word for that specific URL, which helps us in calculating the frequency for that particular word for that specific URL which is stored in that keywords.dat file. After this process is done, we have the frequency of all the words which the user just typed in for all the specific URLs which we have in our search engine. Now, the important part here is to rank the pages based on this criteria, that is frequency of the words. We're using a max heap. So in max heap, we know that it's using a heap data structure, which is nothing but a balanced binary tree data structure where the root node key is compared with its children and arranged accordingly. To implement the max heap, we are using a priority queue in Java. It helps us in assigning the priority to each and every web page. So whenever the priority is assigned to each and every web page, it's assigned based on the frequency of word. So the web page which has the highest frequency of those words will be at the topmost level, and thereon all its children and leaf node will have a lower value when it's compared to the root level. When all the searching and traversing is done, we get a priority queue with its associated priority for each and every web page, and at last we display that priority queue to the user. This is how we are working on the page ranking part, where we are ranking the page based on the frequency of those words. Now I'd like my friend Usha to explain more about similar word suggester.
Thank you, Zorawar. Until now, we have seen how a search works and produces results. But what if a user types in a search word that is not present in our database? In that case, no results can be displayed. That is where this feature of similar word suggester comes in handy. It provides word suggestions that are relevant to the search query. This feature only comes into picture when no link results are returned by the search engine. So, how does this feature work in our product? Firstly, a dictionary is created that stores all the keywords of our database, and then the given search word is matched with every word in the dictionary. For matching, we use the Levenstein distance metric, and edit distance is calculated between the search word and every word in the dictionary. Then a match percent is allocated to each set of the words. Then the first three most relevant words with the maximum percentage are displayed to the user. Now, I would like to give the control to Zoravar to further continue this presentation.
Thank you, Usha. So before our search engine is executed, this is the prior workflow which happens before a user types in any keyword to search anything on a search engine. So we specify a URL domain which is then inputted in our web crawler parameter. So web crawler finds all the URL in that particular domain. After it has fetched all the URLs in that domain, it stores all the URL in a text file in a file system. After all the URLs are then stored, so here our file system is acting as a database. So that's why we have mentioned it as a URL files database here. We convert all the URL files into text files one by one, and we again store it in our local storage. After the text files have been converted, we then extract all the keywords out of those text files and we store it in a keywords.dat file, which can be used for faster access when searching any keyword typed in by the user. Now this is a sequence diagram for a search engine. So herein an user which types in the words to search on a search engine then looks up in the database. If it finds the words, then it ranks the web pages based on those words, it returns the result. If not, the words are not present, it looks up the word suggestion dictionary, it returns the word suggestion, and finally we display the result to the user. Now this is the list of our project explorer, which shows a list of classes like the crawler, extract keyword, generate text file from URL, store hash map, word suggester. All happens before our search engine is executed. This is behind the scenes work which we are doing, and as you can see, we have a list of files stored in as a keywords map.dat, which is stored in a keywords folder, and the dictionary file is used for the word suggester in our search engine. And we are also storing a URL map which is in a key value pair of string as a URL and the integer stored as an index of that particular URL. Now herein I will explain you more about our search engine, and I will also show you the product's demo. Now in our product demo, I'll show you how our search engine works. So for our search engine to work, we implemented these many classes, and this one is the main class search engine.java. But for it to execute, we had to do some work prior to it. For the crawler part, extracting the keywords, generating the text files, and the web page ranking hash map was done prior to it. So this is the structure of our project, and herein we are storing the keywords for the specific URL, and we are storing a string and an index for a specific URL. Now let me show you how our web search engine works. Looks like I have not typed in the correct keyword, so it gives me suggestions. So it's giving me 3 suggestions based on this keyword. here. So I'll take in the first keyword. It works on the edit distance algorithm here, and it gets the associated words for it. So I'll again search on this particular keyword which it was giving me a suggestion on. It's able to find two links for this particular keyword. It's able to also calculate the frequency. This frequency is only for the display purposes. The frequency calculated here is showing as 1, so it was able to find this word at a singular instance for this particular link. It was not repeated more than once. So that's why it's showing as 1 and it's able to find two links. Now let me try it with two words. Now it's able to find 5 links. As you see, the first link has the highest frequency, that's why it's displaying at the top, and all other have the same frequency. Now here we are using a priority queue, so the first link has the highest priority when it's compared with the others. So all the others links are coming in as the way it's stored in the priority queue, but if someone has the highest frequency, that particular link will be displayed at first. So that's why it's showing as frequency 2 and it has a frequency 1. So all these links have the same frequency. It can be displayed in any order of fashion, but any link which has the higher frequency, or it's more than 1 or more than 2 for that matter, will be displayed first. So in a search engine, whichever link has the highest frequency of word occurrences in its particular link, it will be displayed at the topmost position here for a search engine. Now I'd like to give back the control to Usha so that he can explain you more about the future scope which we can work on in our search engine.
Thank you, Zoravar, for the live demo. We do realize that our search engine can be enhanced in many ways, and these are a few enhancements that can be done as a future scope. Firstly, the current page ranking algorithm that we use only takes in the URL index and the occurrence of the search word. This algorithm can be enhanced for better results. Secondly, we haven't done a graphical user interface, which can be implemented in future scope. Thirdly, our search engine doesn't take into account special words such as and or. It considers them as normal keywords. This feature can be enhanced to include or exclude results based on query-based commands, that is and or. Also, we can do better memory management by caching the results so that same searches can give faster results during future searches. Thank you for taking your time and for listening to our presentation. Thank you.